Hello, my dear students. This is Karthik, heartily welcoming you all to Vista's Learning. So, in today's class, we'll be starting with a new topic of class 12th mathematics. So, which topic are we going to start with today? So, today we are going to start with one of the most important branches of mathematics that is called as probability. So as you can see, the probability is highlighted here and the words surrounding the probability are the terms related with it. So we are not going very deep into it. So I know that you've been studying probability from class 9th, correct? Class 9th you had probability, class 10th you had probability, class 11th also you have studied probability, class 12th also you'll be studying probability. So in class 12th what are you going to study is, you're going to study some advanced topics in probability. For example, you'll be studying about conditional probability, you'll be studying about the Bayes theorem, you'll be studying about the binomial distribution, mean, variance, and I think that's it. So these are the topics you'll be studying in class 12th of probability. Alright, so let us begin. But before we start with class 12th probability, so the very first class of probability, what we'll be doing here is, we will be just brushing up our basics. So why are we doing this brushing up of basic, students? See, in 12th you're studying some advanced topics, right? So to be very thorough with those advanced topics, okay, you need to be very strong in your basics. So just for those concepts, on like having a strong hold on the concepts of class 12th probability, we will be brushing or we will be going through our basics today, understanding them very well. Then we'll be starting with class 12th of probability. So maybe in our next session, okay, we'll be starting with class 12th probability. In today's session, we'll be starting with the basics of probability. All right, so let us start with that. The very first question, what is probability? And you can see a boy pondering over this question. So basically, what is probability, students? Probability is nothing but chances of occurrence of an event. So for example, now the time is 2:40. All right, so if they ask you, so around 5 o'clock or 6 o'clock, it is cloudy. Okay, the environment or the atmosphere in this particular locality is cloudy. And the question is, will it rain today or will it not rain today? Correct? Probability, right? So your friend or somebody else might answer, probably it might not rain today. Correct? Have you heard this word? Probably it might not rain today, or probably it might rain today. Correct? So probably is nothing but what? It is a chance, that's all, of occurrence. Occurrence means what is occurring here? It will rain or it will not rain. That is the occurrence. Of an event, what is an event here, students? Event is nothing but raining of water. Understanding? So this is a very small example associated with probability. So what is the definition of probability? Chances of occurrence of an event. So we'll see the next one now. Okay. Mathematically, probability is defined as, so this is how the probability is defined mathematically. As you can see on the screen, probability of an event is equal to favorable outcomes divided by total number of outcomes. So students, in this slide, what you have to remember is those two definitions. So you have to remember these both definitions here. Okay, so this is number one, chances of occurrence of an event. This is the definition of probability. And number two is mathematical definition of probability. So this favorable outcome by total number of outcomes. So to make this even more shorter and easier for you to remember, so you can use like this, students. P, that is nothing but probability, is equal to favorable by total. This is called as probability. All right. So what is favorable? What is total? Everything will be understanding with some examples. All right. Moving on to the next slide now. So here there are some basic terms related with probability. I said you right. We are going to study some advanced topics in class 12th. I mentioned those topics as well. To have a very good hold on those topics, what you have to know is the basics. So these are the basic terms which are associated with probability. If you are very good with all these things, okay, automatically what will happen? You will understand your class 12th probability very easily. So that is all the objective of having this class. Correct? The basic class. So once you're okay with these terms, once you got this all these terms and concepts, okay, class 12 probability will be very, very easy. Okay, so you see the terms related with probability here. activity or an experiment, event, sample space or total number of outcomes, favorable outcomes, and types of events. So these are all what? The basic terms associated with probability. So here the last fifth term, if you see, associated with probability, that is types of events. So we'll see what is an event first, then we'll see the types of events. All right, moving on to the next one. Okay, understanding the basic terms with an example. Now students, I had mentioned some basic terms, right? So we'll understand those terms with a very simple example. Okay, let us begin with this. Okay, yeah. So see this. So what can you see here? There is a coin which is continuously rotating. So now let us take one example. So here, this is a ground. Okay, and there are two captains. There is a cricket match held. Okay, there is a cricket match held here. The cricket match is between India and Australia. Okay, so the captains go on the field. One of the captain flips the coin. So when the coin is in the air, this is how the coin rotates, as you can see there. Heads and tails, correct? A coin has two faces. One is heads, another is tails. So when a captain flips a coin, one of the captain calls heads. So let us assume that Indian captain calls heads. Now the question here is, what if the coin lands on heads? If the coin lands on heads, this implies India has won the toss. Once India has won the toss, what can they do? They can either elect to field or to bat. So there is an advantage, right? Advantage of a choice. Correct? Advantage of a choice in the sport. So if you win the toss, you will be, rewarded with the choice. Either you can field or you can also bat. Understanding? So what is favorable for India now? What is favorable? So favorable outcome you saw there, right? So what is favorable? Favorable is nothing but what we want. Okay, what do we want? Now let us take this example. Indian captain has called heads. Now what do we want? We all want heads, right? If Indian captain wins the toss, then he'll be provided with a choice, either to field or, either to field or to bat. Correct? So favorable is nothing but what we want. Now you have to replace this we with question. Whenever you're doing the problems, what the question wants, okay, that will become favorable. Always remember this. Favorable is always what we want or what the question is like asking. Okay, so that is favorable. And what I have told you, student, what is probability? Probability is nothing but favorable by total. Okay. Now what is this total? This total is also called as, if you go to the previous slide and see, okay, so see the point number 3 here, sample space is also the same and total number of outcomes is also the same. Both mean the same meaning. So total number of outcomes means, now see students, see, what are we considering? We will consider activity first. Okay, activity. So in this example, what is activity? Activity is nothing but tossing a coin. Correct? Tossing a coin. As soon as you finish writing activity, what you have to write is, you have to write the sample space, that is denoted by a capital letter S. Means whenever you perform this activity, what are the possible outcomes? Understanding? So when you flip a coin, what are the possible outcomes? Either you will get heads or you will get tails. Will you get anything in between that? Never. Okay, so either you're getting heads or tails, right? So here the sample space is given as H, comma, T. Correct? Means when you perform this activity, what are the total number of outcomes? The total number of outcomes is nothing but either you will get heads, comma, or you will get tails. So here you can write N of S, means what are the number of elements inside S? Count how many elements are there. So this is 1, this is 2. So here we will write it as 2. So the number of elements in the sample space is equal to how much? 2. How did we get this 2? From the activity. The sample space changes based on whatever activity or an experiment we are going to conduct or do. Understand? Now we'll write the probability, students. So here, what is an event? So see, this is okay, this is favorable outcome, means what we want. Okay, this is an activity. What are we doing here? Here we are tossing a coin. Next we'll do some other activity. All right, I'll explain you that. And what is the sample space here? Sample space is nothing but total number of outcomes. Okay, so here we'll write again activity tossing a coin. Favorable outcome. So what did the Indian captain call, students? The Indian captain has called heads, right? So our favorable outcome is heads. Okay, we need heads. Okay, and what is sample space? Sample space is nothing but h comma t. Again, you can write n of s, means the number of elements in the sample space is equal to 2. Okay, so activity is done, favorable outcome is done, total number of outcomes is done. So now, what is event here? What is an event that is going to occur? See, 2 captains are standing. One of the captain has tossed the coin. Another captain has called it as heads. So now here the event is nothing but heads. Correct? Because we need heads, right? If we get heads, we win the toss and it goes on like that. So event is nothing but here getting heads. Or this might also become or getting tails. Anything can be there. All right. So how do we write this now? Probability of getting heads is equal to favorable divided by total. This is what I told you previously, correct? What is P? P is nothing but F by T. What is F? Favorable outcome. And what is T? Total number of outcomes. So what is our favorable outcome, students? What is our favorable C here? See F here. What is our favorable outcome? The favorable outcome is nothing but heads. Correct. So how many heads are there in the sample space? Count how many heads are there in the sample space here. Yeah. How many heads are there in the sample space here? There is only one heads, right? So here you can write n of F, means the number of favorable outcome what we want, that is equal to 1, and n of S, this is equal to, means total number of outcomes, favorable outcomes. Now what is probability? You can write P is equal to n of F by n of S, which is equal to 1 divided by 2. So what is this 1 divided by 2, students? This 1 divided by 2 is nothing but probability of getting heads. Understood? Probability of getting heads is nothing but equal to 1 divided by 2. So here again we will see probability of getting tails. Probability of getting tails. Directly we'll write. Okay, we'll write it directly. How many tails are there here? Can you just check out? There is only 1 tails, right? So write 1 divided by total number of outcomes 2. So probability of getting tails also will be equal to how much? 1 by 2. Probability of getting heads is 1 by 2. Probability of getting tails is also equal to 1 by 2. Understanding? Which means whenever you toss a coin, there is a 50% possibility that it will be heads, and there is also 50% possibility that it will be tails as well. How are we telling this 50% possibility? That is by using the concept of probability. What is probability again? Favorable outcome divided by total number of outcomes. Okay. So this was one example where we had seen activity, favorable outcome, sample space, event, and probability of the events. We'll move on to the next one. Understand these terms very nicely with another example. All right. So moving on to the next slide. So understanding the basic terms with an example again. So here we have taken another example, as you can see on my background. So I'll just play this once. Okay, so I think there is some technical problem here. It is not playing, it's not getting played. All right. So what is happening here? As you can see a hand here, right, students? So you see this white part inside his hand. So that is nothing but a dice. So dice, I think you have all played snakes and ladders, right? So this is a dice. So that is nothing but a cube. And how many faces does a cube have? A cube has 6 faces. Correct? You can count here. So this is 1, 2, 3, 4. Front face is 5. Okay, back face is 6. So there are 6 faces in a cube and each face has one number on it. So what will be the sample space? So again, we'll start with the activity. What is the activity here? Rolling a die. Okay, rolling a die is the activity. What is the sample space? Means when you roll a die, what is the total number of outcomes? Total number means if you roll a die, what all answers or what all results will you get from that particular activity or experiment? So that is nothing but what is the sample space here? The sample space will be 1, 2, 3, 4, 5 and 6. So when you roll a die, either you will get 1 or you will get 2 or you will get 3 or 4 or 5 or 6. Any one number you will get. Will you get 7? Never, because a die has only 6 faces, right? So 7 number you cannot get. Correct. So what can we write here? Here we can write n of s means the number of elements in the sample space is equal to how much? 6. Now let us assume that you want 2. Okay, the number 2 you want. So once you get the number 2, you are declared as a winner of the particular board game you are playing. So it might be anything, snakes and ladders, Ludo, business, Monopoly, etc. and etc. All those are very fun games. So now we'll come back here. So here we'll write favorable. What is our favorable? Our favorable is number 2. So if we get number 2, okay, we will be declared as a winner. So that is why I want number 2, students. All right. So now what is the probability of getting number 2 then? We'll write P of 2. Okay. What is P here? P is nothing but favorable by total. What is our favorable, students? See here. This our favorable is number 2. How many number 2s are there in the sample space? There is only one number 2, right? So in the numerator, what you have to write here? 1. Favorable is 1. What is the total number? Total number is 6. That is already written here. So that is nothing but 6. So P of 2 is nothing but equal to 1 divided by 6. Understood? So similarly, we'll see some other numbers here. So P of 2 we got 1 by 6. We'll write the sample space again. 1, 2, 3, 4, 5 and 6. Now let us see what is P of 1. P of 1 is also 1 by 6. Correct? What is P of 2? We already saw that is 1 by 6. What is P of 3? 1 by 6 again. What is P of 4? This is also equal to 1 by 6. What is P of 5? That is also equal to 1 by 6. What is P of 6? That is also equal to 1 by 6. How many elements are there here, students? 6 elements are there, and we have taken out the probability of all the 6 elements. Correct? We have taken out the probability of all the 6 elements. Now add all the probabilities of all the 6 elements in the sample space. So that is nothing but P of 1 plus P of 2 plus P of 3. This will go on until plus P of 6. So here we'll write 1 by 6 plus 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 1 by 6. All the denominators are same. Correct? Observe all the denominators. All the denominators are 6, which means we can add up the numerators. So that will give us 6 by 6, which is equal to 1. Correct? So what did you understand from here? From here we understood that whenever any activity is conducted, okay, understand, whenever any activity is conducted, and if you have the sample space of that particular activity, and you find out the probability of each and every element in that sample space, and you add all those probabilities, always that will be equal to how much? Okay, so here you can see that will be equal to 1. In the previous example also, we'll just see that. Okay, so this was our previous example. We had, so in the sample space there are only 2 elements, correct? One is heads and one more is tails. Add both the probability, students. So that is nothing but P of H plus P of T. Okay, so what is P of H? 1 by 2. What is P of T? 1 by 2 again. So half plus half will be equal to how much? 1. Correct? The same thing whatever happened in dice is also happening in coin. So what did you understand? Make a note. Whenever an activity is conducted, the sample space of the activity is recorded. Each element in the sample space, if you take out the probability of each and every element in the sample space and you add all those probabilities, okay, that will always be equal to 1. A probability can be lesser than 1, but a probability can never be more than 1. So whatever I have told just now, you can rewind that and make a note of whatever I have told you. Very important this is. All this brushing up we are doing it for a very strong hold on class 12th advanced topics of probability. Alright. Okay. So apart from this, now I'll show you something else. Okay, so students see here. So here we will. Yes. So what we wrote very recently, okay, I'll write that once again. P of h plus P of t equals 1. That is nothing but 1 by 2 plus 1 by 2 equals 1. So this was the last thing which I told and explained to you. Alright. Now see this. We are going to change some things now. Okay. This P of t can also be written as P dash of h. P of h we know, right? What is P of h? Probability of getting heads. How is P of h read as? P of h is read as probability of getting heads. Now, how is this read as, students? How is P dash of h read as? P dash of h is read as probability of. This dash is nothing but, okay, that dash is nothing but not getting heads. If it is not heads, then what is it? So in a coin, already see, okay, I'll write the sample space also here. Sample space is equal to h comma t. Now understand this, students. Okay, so we are conducting one experiment. That experiment is tossing a coin, and we have also written the sample space. Understand what is sample space? Sample space is nothing but the total outcomes in an experiment or activity. Both are same. Okay. So what are the total number of what are the total number of outcomes in that experiment? Either it will be heads or it will be tails. If it is not heads, then what is it? It is tails. If it is not tails, then what is it? It is heads. So can this be written like this now? This can be written as P of h plus, instead of P of t, what we'll write? We'll write P dash of h. P dash of h is, see this, P dash of h, this is nothing but equal to P of t only, correct? If it is not heads, then it is tails. So P of h plus P dash of h is equal to how much? 1. This is a formula. Okay, this is the formula for this example. So generally how you can write is, so generalized you can write it like this, students. Okay, you can write it like this. P of any event A plus P dash of that event A will always be equal to 1. So this is a generalized formula. So I'll write formula here as well. Make a note of this. Okay, very important formula. You will be requiring this in class 12th as well. So this is just brushing up, students. The same thing, okay, P of A plus P dash of A will apply to the next example as well. That is nothing but rolling a die. All right, we'll go to that. Yes. So here we'll take, what is P of 2? Means when you roll a die, what is the probability that you will get 2? That is nothing but 1 by 6. Now what is P dash of 2? So to write P dash of 2, what we'll write here first? We'll write here the sample space. Sample space is equal to 1, 2, 3, 4, 5, 6. What is this read as, students? This is read as probability of getting not 2. Okay, so this is not 2, this is not 2, this is not 2, this is also not 2, this is also not 2. If this is not 2, then what is this? This is 1. If this is not 2, then this is 3. If this is not 2, then it is 4. If this is not 2, then it is 5. If this is not 2, then it is 6. Understanding? If it is not 2, then what is it? It is something else. In the previous example, we had only 2 outcomes. It is either heads or tails. In this example, we have 6 outcomes. So if it is not 2, it can be any remaining 5 of them. So what are the remaining 5? 1, 3, 4, 5, 6. Correct? So all these are not 2s, as you can see on the screen. So what is the probability of not 2? Count how many are there. 1, 2, 3, 4, 5. So there are 5 elements in the given sample space which are not 2. So that will be written as what? 5 divided. That is our favorable, right? What is our favorable? Getting not 2 is our favorable. So how many not 2s are there? There are 5 not 2s, as you can see on the screen. And what is the total number of outcomes here? The total number of outcomes is 6. Now add them both, students. So P of 2 plus P dash of 2 will be equal to how much? 1 by 6 plus 5 by 6. So what is 1 by 6 plus 5 by 6? 6 by 6, which is equal to 1. So again, what happened? We have proved that same formula. Understanding? So this is nothing but another example of rolling a die here. Here, a man is rolling a die and we are calculating the probability of getting 2 and not getting 2. Okay. Apart from this, what else you have learned in your class 11th basics? Okay. So there is one law, students. Okay. There is one special law where you can use in probability. Very simple law. There are 2 uses of this law. Okay. This law is called as Pascals Triangle Law. Okay. I'll just write down here. Okay. This law is called as Pascals Triangular Law. Okay. So what is the use of learning this law? Will this law be useful in solving the problems of probability? Obviously yes. 100% yes. Okay. So where is this used? But this is used in writing down the sample space of coins. Sample space of coins. There is another use of this law, and that use is nothing but expansion. Expansion of algebraic terms. Okay, so let me explain this Pascal's law to you. So students, this Pascal's law has 2 different uses. You can either use it here or you can also use it here. Okay, so let us see this Pascal's triangular law now. Construction you have to do first. So you have to first construct the Pascal's triangle. So how do we construct that Pascal's triangle? Start with 1. So here you write 1, 1 and 1. Correct? Easy. 1, 1, 1. Write 1 here again. Write 1 here, 1 here again. Write 1 here, 1 here again. Write 1 and 1. Okay, students, triangle has 3 sides, right? Now 2 sides are ready. Third side we have to fill. So now students, what is 1 plus 1? 1 plus 1 is 2. Correct? 1 plus 1 is 2. 2 plus 1, 3. 2 plus 1, 3. 3 plus 1, 4. 3 plus 3, 6. 3 plus 1, 4. 4 plus 1, 5. 6 plus 4, 10. 6 plus 4, 10. 4 plus 1, 5. Did you understand this? Only addition, that's all. But you have to be very careful. So the very first thing what you have to do, on this side write ones, on this side also you write all the ones. Okay. Then you have to start 1 plus 1 is 2, 2 plus 1 is 3, 2 plus 1 is 3, and it goes on. Okay, now we have written this. How to make use of this? So what we'll do, we'll change the color here. So first I'll tell you about the coin, students. About this I'll tell first. Sample space of coins. So see this. This is indicating sample space of 1 coin. This is indicating sample space of 2 coins. So only 1 coin we have discussed, right? So further we'll be discussing 2, 3, 4 and so on. This is indicating the sample space of 3 coins. This is indicating the sample space of 4 coins. And the last one, this is indicating the sample space of 5 coins. Understanding? So what is expansion, algebraic of expansion terms? So I'll show you that now. Okay. So we'll change the color here again. Okay. So this is indicating a plus b whole to the power of 1. This is indicating a plus b whole to the power of 2. This is indicating a plus b whole to the power of 3. This is indicating a plus b whole to the power of 4. And this is indicating a plus b whole to the power of 5. Understanding? So 1 coin, 2 coin, 3 coin, 4 coin, 5 coins. So until 5 coin sample space you can write. See, I'll tell you, as the number of coins increases, writing down the sample space becomes more and more confusing. It becomes very confusing. To avoid that confusion and write the sample space very easily, we are using Pascal's Triangular Law. Same thing with the expansions. So I think you'll be knowing a plus b the whole cube. That is the last expansion you know. So if I ask you what is a plus b whole to the power of 5, you definitely don't know that. Correct? So now how to tell that on spot? Simply draw a Pascal's triangle. So you can easily tell what is the expansion of a plus b whole to the power of 5. Very easy it is. Okay, now let us see how is this used, students. So how is it being actually used? So let us use the red color again. Okay, I'll explain about the coins first. Then we'll go back to the algebra thing. Okay. So students, let us start here. Yeah. How many coins are there here? 1 coin is there. So this is h to the power of 1, t to the power of 0. Correct? H has 1, t to the power of 0. Now what will happen? As we move from left to right, okay, as we move from left to right, the power of the heads will decrease and the power of the tails will increase. Now we are moving from left to right, right? H will decrease, it will become 0. T will increase, that will become 1. What is the initial power here? The initial power is nothing but the number of coins being used. Understanding? Now in the next one you see, how many coins are there? There are 2 coins. Correct? So what is the initial power of h? 2. So h to the power of 2, t to the power of 0. Move on from left to right, h to the power of 1, t to the power of 1. Again move from left to right, h to the power of 0, t to the power of 2. Now see, here how many coins are being used? 3 coins are being used. So that is nothing but h to the power of 3, t to the power of 0, h2, t1, h1, t2, h0, t3. Here 4 coins are being used. Correct? h4, t0, h3, t1, h2, t2, h1, t3, h0, t4. Okay. Now see, what is the sample space of 1 coin? We have already done that experiment, right? So S is equal to h comma t. Sample space of 1 coin. Now you see the sample space of 1 coin in Pascal's triangle law. 1 head, 1 tail. That is what is written here. So I think you will also be knowing what is the sample space of 2 coin, students. So you have studied in the lower grades only. So I'll write down the sample space here. So the sample space of 2 coins is written like this. H, okay. Sample space of 2 coins is written as HH, HT, TH and TT. Correct? Pascal's triangle law. So this is h to the power of 2, t to the power of 0, h to the power of 1, t to the power of 1, h to the power of 0, t to the power of 2. Now see the students. 2 heads, how many are there? 1. Check. Correct. 1 head, 1 tail, how many are there? 2. See here, 1 head, 1 tail, 1 head, 1 tail, how many are there total? 2. 2 tails, how many are there? 1. So 2 tails, 1 are there, that is also right. So similarly, you see here, what is a plus b whole to the power of 2? A square plus 2ab plus b square. Very simple, what you have to do, replace h with a and replace t with b. What will happen? So just replace and see what will happen here. A square b to the power of a square b to the power of 0. Okay, so this is 1 2 1 here. a1 b1 and this is a to the power of 0 b square. So what do we had here? A plus b whole to the power of 2, right? So that is nothing but a square plus b square plus 2ab. Now check out, students. 1a square, 1a square, 1b square, 1b square, and 2ab. Here also we have 2a and b. Correct? So see, I think you got this. If not, just go back, watch the video once again, you will definitely get it. If you're still not getting, please do let us know by commenting in the comment section. Okay, we will help you out with some other things. Alright, so apart from this, Pascal's Triangle Law, we'll come back to that. It is used in two different ways. One, in detecting the sample space of n number of coins. Any number of coins you can find out the sample space without any mistake. Okay, and even the algebraic expansions like a plus b whole to the power of 6, a plus b whole to the power of 10. Okay, all those things can be written with the help of Pascal's Triangle Law. Apart from this, we also have another topic to be discussed, that is nothing but sample space of cards. So students, what are cards? Playing cards you have all seen, right? So in casinos and all, playing cards is very famous. What is happening in this playing cards is there is a pack which is available in the shops. So you can go and purchase it. I hope you have definitely paid it. Okay. So in this pack of cards, there are 52 cards in total. Okay, you have to know this information as well, very important. There are 52 cards in total. This 52 cards has been divided into two basic colors, that is one color is red, another color is black. Red is divided into two shapes again, one is the heart, another is diamond. Black is divided into two shapes, one is the spades and another is clubs, like this. And under each shape we have 13 cards. What are those 13 cards? A, 2, 3, 4, 5, 6, 7, 8, 9, 10, J, Q and K. Alright. So these are the 13 cards under each suit. Suit is nothing but the shape, students. Okay. Under heart we have 13 cards. So red will be having 26 cards. Black also will be having 26 cards. Under red we have two shapes, heart and diamonds. Heart will be having 13 cards. Diamonds will be having 13 cards, spades will be having 13 cards, and clubs will be having 13 cards. So what are those 13 cards? These are those 13 cards, A to K. Okay, and in this, J, Q and K are called as face cards. Remember this, very important. J, Q, K are called as face cards. Now the question, students, how many kings are there in the card? So in a pack of card, what are the number of kings? The number of kings are 4. Which are those 4 kings? King of hearts, king of diamonds, king of spades and king of clubs. How many number of 5 cards are there? Means number 5 cards here. This 5 card, how many are there? 4. Which are those 4 cards? 5 of hearts, 5 of diamonds, 5 of spades and 5 of clubs. So we have discussed the sample space of coins. We have discussed the sample space of cards. There is one more sample space which we have to discuss about. Okay, that is nothing but about the dice. So dice is very simple, students. So if you're rolling, okay, only one die, if you're rolling only one die, what is the sample space? N of S will be equal to 6 to the power of 1. What is 6 to the power of 1? 6. Right? So when you're rolling 2 dice, N of S will be equal to 6 to the power of 2, that is equal to 36. When you're rolling 3 dice, N of S will be equal to 6 to the power of 3, which is equal to 216. So this much you have to remember about the dice. Okay, this much you have to remember about the cards. And about the coins, you have a special weapon called as Pascal's Law. With the help of that, you can find out the sample space of 1000 coins as well, but it will take so much of time. Alright, so that is all for today's class. We have done the basics, whatever is required for the advanced concepts of class 12th probability. I'll be seeing you in the next class with class 12th probability. Until then, take care and stay tuned with this class learning. Thank you so much.